Welcome to the next lecture, and in this video I will be continuing with the design modeler geometry what we have created. So it depends on the user as to select or create any model and choose any of it to be proceeded for the next steps in simulations. So I will be going with the design modeler, and I will be just double clicking on the mesh, and I have already explained the importance of grid discretization or domain discretization, and all those things were already discussed in one of my other courses, and I cannot repeat all those things because it will take a lot of time, and that is the probable reason I'm just continuing with the discussion of simulations and projects, associated projects. And well, the major objective of the mesh is the meshing module is to divide the complete domain into small elements. Okay, we are dividing the domain into small elements, and those elements may be termed as control volume, and in each control volume or each element we will be the software will be solving the governing equations that govern the fluid flow. Okay, so we know that all the flows in nature are governed by the governing equations: the momentum, the continuity, and the energy equation, right? So we will be utilizing these three equations. I'm sorry, I'm not the software is utilizing basically, and along with some turbulence model, and it will be solving the equations on each control volume and giving us some results in terms of numericals, right? So CFD is all about numericals, and we have to see that we are solving the case appropriately to get the appropriate result. And always it requires us to some form of references or something to compare our results with, because as I mentioned that CFDs with respect to numericals, it is not always necessary that what I am doing in the first attempt is appropriate or what you are doing in the first attempt is incorrect, right? So it depends on cases to cases. Different equations are utilized for different applications, and one already one gains this experience of judging the simulations or analyzing the simulations or performing the simulations based on experience. So if you're a beginner, don't really worry about it. I'm really sure that with respect to your time spent in performing simulations, comparisons with experimental data or some reference data or any form of comparisons with your CFD results, and if you're able to compare and verify and validate your results appropriately, then I'm really sure that you will be gaining a lot of knowledge in CFD, especially with respect to your research interest. Now coming to the bottom point, we have to perform the mesh over here. Now as I mentioned that we are just dividing the mesh in ANSYS Fluent, the ANSYS meshing module what you have, this is a very basic meshing features we have over here. If you want to create a very core kind of mesh, very clean mesh, then you can create over here, but it depends. If your case is complex, then you better have to use some other meshing software such as ICM clear. But if you are able to create a normal tetrahedron mesh, okay, unstructured mesh, what we can call in simple terms, then we can just stick with it and we can just perform the simulation. End of the day, your goal is to see that your simulation is giving you appropriate results no matter what meshing module you're using with. Okay, some people are comfortable with the automatic meshing what is available over here. Some people are comfortable with creating ICM meshes. Okay, and again it depends on user to user, objective to objective, geometry to geometry, right? But remember, the end goal is to get an appropriate result, a proper converged result, right? That is the end goal over here, and I will not be sparing time in ICM CFD because that is another topic of course. So we will be creating an automatic mesh over here. Firstly, we will be creating a simple generate mesh, and we will see what is the kind of mesh the software is creating. So the software is trying to create a structured mesh over here. You can see it is aligning the elements in appropriate manner, but internally the elements are kind of unstructured, right? So what I generally prefer is I will be preferring some unstructured mesh over here. So I'll just click on mesh, right click, insert, I'll go to method, and I need to select the geometry at first. I'll select this geometry and click apply. Now in the method, by default automatic is selected. I will be selecting the tetrahedron rather than hex dominant. So the kind of mesh what you're finding right now is a kind of structured mesh, which is nothing but hexahedron mesh, right? The elements are cube in nature and cube shaped in nature actually, so we can just term them as hex mesh, but I will be preferring tetrahedron, and you will be finding tetrahedrons being created when I'm just clicking on generate. The conversion is happening at this moment, and you have this respected tetrahedrons being created. So this is a pure unstructured mesh. Now what we can do is towards the wall we can create structured mesh, okay, and in the middle region we can just leave it as unstructured. So that changes we can perform using the mesh editing options over here, which are listed in this ribbon. Clear? Now the reason for creating a structured mesh kind of layers at the wall section, that is the circular section, is because to maintain a respected y plus value, right? Now y plus determines the usage of wall functions, okay. If you are planning to keep your y plus somewhere greater than 30 and lower than 300, then you are probably going with the standard wall functions what we have, and I will be choosing the same thing. Clear? Now in order to calculate the y plus and what is y plus, yet again I've explained that in my previous course, and that I've kind of spent a complete section on that topic, okay. And I mentioned that we can calculate it online as well, so we have some calculators available over here, and I've already fed the data over here. The velocity of the water which will be pumping inside will be something around 0.3 meters. Clear? The density of the fluid is, that is the water, is something around 998 or 1000 kg per meter cube. The dynamic viscosity is this value. The length of the pipe is 1.5. We will be targeting a value of 50. The targeting a y plus value of 50, and if I'm just computing, I will be getting the wall spacing. So this should be the spacing of my wall, okay, that is 0.003. Clear? So what I'll be doing is, firstly I'll just see what is the mesh count over here. I'll just click on mesh, go to statistics, and in the statistics you can see the elements over here, that is 20,000 elements. And you can see the element size, the default element size is 7.5 e minus 2. So I'll just convert it as 1 e minus 2, from 7.5 e minus 2 to 1 e minus 2. So this will indicate a smaller size elements, and which will increase the mesh count quite effectively. You can see the elements have been increased to 71k, or 71,000 you can say. Or if you want, you can just go with more, because this is just a conceptual study. We are just performing a simple mesh, okay. So I believe we can just stick with this thing. But now what I need to do is, I need the mesh or the elements which are closer to this wall to be structured and arranged in the form of layers. So for that thing to perform, we have something called as inflation over here. I'll just click on this inflation and select the geometry at first, click apply. Geometry selected. Now I need to select the boundary, and for the boundary I'll just select the wall over here, and you can see, just rotate your geometry and see whether the complete wall is selected. Click apply. Now wall is selected. Now the inflation option, in that I'll be going with the first layer thickness. The first layer thickness as per the calculator must be 0.0037. So I'll just maintain it as 0.03003, and the maximum layers I'll be just keeping as 5, and I'll just click on generate over here, and after generating it will solve it, and you can see we are getting a message 5% meshing completed, 100% is completed. Now I'll just zoom in over here, and you can see the mesh size is mesh is arranged in a structured fashion, okay. Now the y plus value what I've selected is 50, that is little high, okay, and the velocity is low, and that is corresponding to a Reynolds number of 4.5 448,000 I'm sorry, a Reynolds number, and the respected first cell height is represented over here, and you can see it is quite thick, okay. But if your velocity is high and y plus value is less, for example if your y plus value is 1, okay, if you don't want to utilize the wall functions and you rather want to resolve the viscous sublayer, then you have to probably target a value y plus value of 1. In that case, you can see when I'm computing, the wall spacing is reducing drastically. It is almost, you know, 4 zeros, and in the previous case it was 3 zeros. So you can see the difference in the variation of first cell with respect to the targeted y plus value. Okay, so this is a kind of coarse simulation, we can say. Okay, the mesh is quite coarse, and just click on mesh. You can see the increment a bit because we are arranging them in a bit what do you call, as per the structured layer. Clear? And now what we need to do is, as we have completed the meshing part, we probably need to name the sections. Okay, so this will be the wall of the pipe, and this will be the inlet, and that will be the outlet. The first and foremost thing is, let me arrange appropriately, because sometimes what will happen is we will be selecting this as inlet, the flow will be in this direction. So I want this to be my inlet, and this will be my wall, and this will be the outlet. Now you can see the name sections over here. Our naming is done. This is the wall, and this is the outlet. Now I'll just go to the mesh, click on update, and you will be getting a message over here that is, the mesh translation to Fluent was successful. If you're getting this message, everything is fine. And what is this? I'm sorry. Yeah, so we can just close the meshing module, and we can just go to the setup over here. That is the next task. So let us just catch up in the next video.